plus 4/9 plus 2/9. That is actually just going to be equal to 6/9. Now, what does that number represent? That number represents actually the expectation of how many heads you will get, you would expect to have based upon flipping these two coins just once. So this is the expectation of how many heads you would expect to show. So that means that the expectation is 6/9. Now, what does that mean? That means then that if I was to go ahead and take a look at this experiment and do it and perform this experiment, I would actually come up with the expectation of 2/3 heads showing up every time that I do it. Okay? So what we can do then is we can go ahead and generalize and say that in general, okay, the expectation of any random variable, and again notice that that's a capital X, is going to be the summation from I is equal to 1 to n of p sub I, which is the probability associated with that particular random variable value. Okay. So let's go ahead and take a look at how we want to use this formula here and show the relationship here. So let's say, for example, that I have this particular distribution probability table. If I wanted to go ahead and calculate the expectation of getting a heads, the expectation of getting a head is going to be equal to the summation from I is equal to 1 to 1, 2, and 3. So 3. Because this is the first, second, and third possible value that I can have of p sub I, x sub I. Okay, so if I wanted to go ahead and show what the I actually represents here, this is when I is 1, 2, and 3. So I can then say that this is going to be p sub 1, x sub 1, plus p sub 2, x sub 2, plus p sub 3, x sub 3. Oh, sorry, h. I need to use h. Sorry. H. 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 Okay? So what I do then is I take the probability, times it by the actual value that it is. Here's h sub I. And this is the probability sub I. Okay, so I would then go ahead and just do exactly the same thing that I did here, 0 times it by 4/9. Maybe I should write it this way instead. 4/9 times it by 0 plus 4/9 times it by 1 plus 4/1/9 times it by 2. And of course I come up with 2/3. Okay, so notice that even though we know that we do not have a possibility of getting 2/3 heads by flipping this coin, we can still go ahead and have this expectation for the amount of heads that are actually going to show. So what this says then is that if I was to go ahead and flip the coin once, I would expect 2/3 of a heads to show. That's what this actually represents. Okay, now it's a little bit hard to kind of get a handle on, I think. So let's go ahead and actually think about what happens when we associate money with it, because of course money is something that all of us understand. Let's say, for example, that you come to me to play this game. And all it consists of is flipping 2 coins, and flipping these 2 unfair coins once. Okay, so here are the 2 coins, and here's the probability distribution table for those 2 coins. Now, let's say, for example, that if you have no heads showing, then you pay me $2. If there is 1 head showing, you still pay me $2. But if all of a sudden you have 2 heads showing, I give you $10. So here you go. let's go ahead and say this. The minus 2 represents the fact that you pay me $2. And let's just use US dollars. Because if you get either no heads or one head, you pay me $2. But if you get 2 heads, I'll give you $10. Do you want to play the game? That's kind of an interesting situation here. So the key to this is to ask yourself, if you were to play this game once, what would you expect your earnings to be? So let's go ahead and use this whole idea again of expectation. So if I go ahead and take a look at E of H, the expectation of how many heads that I come out with, of course we're going to be using the same formula here. But instead of using actually these values over here, which represents how many heads are actually showing, being that that is actually associated with how much money you are either going to lose or how much money I am going to give you, I can now go ahead and say that the expectation of H in terms of how much money is going to be transacted is this. It's minus, let me go ahead and say 4/9 first again. 4/9 of the time, you lose $2. 4/9 of the time, you also lose $2. But for 1/9 of the time, you actually gain $10. Okay, so the question is then, is if I play this game once, what do you expect your earnings to be? So let's just figure this out. This is minus 8/9 minus 8/9 plus 10/9. So what you come out with is negative 16/9 plus 10/9. So this is going to be equal to minus 6/9, which of course is going to be minus 2/3. So we come out with a minus 2/3 here. What does this represent? This represents here that every time that you play this game once, every time that you play this game, the expected transaction is that you're actually going to always have to pay me 2/3 of a dollar. So in other words, every time that you play, you're actually going to have to pay me 67 cents. Okay, and there you go. That's how we can now go ahead and take a look at expectation, and we can go ahead and actually calculate what you would expect the result to be given one particular event, given one performing the event just once. So, taking a look at this, taking a look at that, using this right here. If you have, let's say that again. If you have the probability distribution table, you can always go ahead and calculate the expectation using this formula here, but you have to really understand what this number actually represents. So, there you go. That's how Las Vegas makes all of its money.